In this video, let us talk about functions. Function is a piece of program code which performs a specific task, maybe a small task, but it performs it completely. It takes some input as parameters and return the result as a return value. Functions are useful for procedural programming or modular programming. If we write a function, then we can reuse it in our program multiple times. We can use it, and even we can use it in other programs, and also we can share it with other programmers. And the collection of functions, we call it as a library. Like C++ languages provides a lot of built-in functions in their library, and we commonly use them for making our programming easy. Let us see how we write the functions and what is the idea behind writing functions. See, every C++ program must have a main function, so I am writing void main. Even we can write int main also here, but I am writing void main. So we know that this is the entry point of our program, and our program executes from here only, and whatever we want we write on the code here. Suppose I am writing the code here. Now just listen this carefully. If I have a very big program, I have some 10,000 lines of code, then everything I am writing inside main function only. Then if you have a single function, then this style of programming is called as monolithic programming. And if you write the program like this, let us see what the problems we face. First problem, if there is an error in a single line, then it's an error in the entire program or entire main function. Second problem, 10,000 line of code, I cannot finish it in 1 hour or 1 day. It may take few days, and throughout the time I should remember everything, then only I can make changes or write new lines in the program. So memorizing the whole program. Then the third thing, how many people can write this one single main function with everything 10,000 lines here? Only one person can write. We cannot make it as a teamwork and more than one people are working on the same main function. Not possible. So work cannot be distributed in a team. Now the fourth problem, when this program becomes very big, it may fit in some computer memories, it may not fit in some computer memories. It depends on the size, and that depends on the hardware configuration of the computer on which you are running. So these are few problems due to monolithic programming. Monolithic means everything as a single unit, the complete program as a single unit. So what we prefer is, let us break the program into pieces, manageable and small pieces and reusable pieces. Then the benefit is, I can develop it piecewise, so I can concentrate on one piece at a time, one piece of code at a time. Second thing, the pieces can be distributed among a team of programmers, and they can develop some set of pieces, and we can collect them together and make it as a single program. And definitely the main will be integrating all of them directly or indirectly. Then one more thing, when we are running on some computer, then we can load and unload the pieces that we require, so we don't have to have a very large size memory on the computer in which we are running. So all the problems are solved. So this is nothing but modular programming. This can be done using functions. So let us see how to write a function. First of all, function should have name, function name. Function name must be there. Then it should have parameter list, or also called as argument list, what all the parameters it is taking. Then function should have a return type. What value it is returning, it should have the data type of that value here. So functions are identified by their name, and this becomes input to the function, and this is the output of a function. A function can take 0 or more input, means it may not take any input also. It depends how you are writing a function, what purpose you are writing a function. Then it may return or may not return a value, but it can return at most one value, just one value. A function cannot return multiple values, but it can take multiple values as input, but the output should be only one. If the function is not returning any value, then the return type should be void. Now one more thing, how the function name should be. The rules for giving function names are same as the rules of giving variable name. How you give variable name, same way, same rules you should follow for giving function name also. Now let us write one example function and use it in our main function. I will write main function. Now here I will write one function void display. The function name is display and it is not taking any parameter, so I can leave it empty. This is the function name, this is parameterless, nothing is there, and the return type is not returning anything. Then inside this I will write cout hello. Just this is a wishing message. Now from here, this is the way we call a function, display. So the function will be called. So inside the main function, I am not doing anything, just calling the main function. So let us see how it runs. See, when the main function starts, it will come to this line. So it will go here and execute this and return back and continue the main function. So if I have few lines here and after this also, so the first line and the second line, third line and fourth line. So after first line, it will go to second. So second line, it will execute this, return back, and it will continue with third and fourth line. Now one important thing, that inside the functions avoid user interaction, that is a cin and cout. It's a bad function. You should avoid using cin, cout inside the function. So the function should not interact. So the idea behind that I will tell you. Suppose there is an organization, so main is a manager or the owner of a business, and this is his employee, displays the employee. So who called the employee? Manager has called the employee here for some work. So who should contact or who should communicate with the clients of a business or the customers of a business? Manager or the owner should interact. So cin, cout is like communication with the client. So communication client is, who is client here? User. So through main function only the communication with the user should be done. All other functions must be just supporting the main function. So they should not have cin, cout in them. This is a good practice, so you should avoid it. But for explanation purpose, I may be writing cin, cout. Okay, just for explanation purpose. But when you really develop the application, don't have interactivity inside the functions. Let me write few more functions and show you. I will write a function for adding two numbers, simple function. So add is the name of a function. It has to take two parameters. You can give any data type here, but to make it simple for understanding, I am always taking integer type. So two integer values, I have given the names as x and y. Now after adding them, it's going to return the result. The result is going to be of type integer only. So the return type of a function is also integer. Now here what I will do is I will declare one variable z. Then I will say z assign x plus y. I am just making it a little lengthy. Then say return z. So the value of x and y is added and the result is stored in z and the z value is returned. Let us write a main function and use it. So I will write void main. Just to separate them, I will draw a line. Here I will have two variables, a as value 10 and b value as 15. Then also I will have some variable c. Then I will say add. I will send these two values a and b. And whatever the value it is returning, this return value z, I will take it in C. Then here I will say cout sum is C. That's it. So this is a main function which is calling this function. Let us see how this works inside the main memory. So I will draw the diagram of the main memory and show you. See, we know that the memory is divided into three sections, that is code section and the stack and heap. So this working is very important for you. Watch it and remember it for always. See, there are two pieces of code. So code section will have the code for add function as well as main function. So the machine code will be also in two pieces. We wrote it in two pieces, that will also be in two pieces. See, mostly people believe that the machine code of this add function will be copied at this place. No, machine code will be separate. Two different pieces will be there. Now, program we are running. So this is there inside this code section. So the program is loaded in the code section. Now let us see the working. Main function start. The first line says that it needs variables for A, B, C of type integer. So memory for A and B and C will be allocated. So these bytes are belonging to main function, and this we call it as activation record of main function. And A is having value 10 and B is having value 15. C is empty and that is having some garbage value. Now next there is a call to function add. So the control goes to add. The moment the function is called, then for this function also activation record is created inside the stack containing all the variables used here, x, y and z. So x and y and z, three blocks are created for three variables. Now from here what is passed? A and B. So A value goes into X and B value goes into Y. So this 10 goes into this one and 15 goes here. Now next line, this is already done. This is completed, right? So now Z assign X plus Y. So these two values are added and 25 is stored here. Now return Z. This line is over. Return Z means this value is copied in C, because here if you see, this return value will go into C here. Whatever the function is returning will go into C. So C will contain 25. And once the function ends, it reaches here. Once the function ends, its memory inside the stack will be removed. So its activation record is deleted. So this means we understand that whenever function is called, the memory for all the variables used in that function is created inside the stack, and when the function ends, all that memory will be cleared automatically. And one more important thing, if this function had allocated some memory in heap, that will not be deallocated automatically. Function should release it by saying delete. So new, if it says and get the memory in heap, it must be deleted. So anyway, back to this one. So the function ends. Now the control come back here. Now still main function memory variables are there inside the main memory, inside the stack. Now C out some C. So here 25 is displayed and function main ends. Once the function main ends, its activation record or the memory for all those variables will also be cleared. So this is how the working of the function, and we will write many functions. So practically I will show you some functions, and I'll give you some challenges for writing some functions. Let us learn how to write functions. I am writing a function here, void display. This will just display some message, cout hello. That's it. Now from main function, I will call this display function. Let us run this. I got a message hello here. Let me debug this. Now it is at the start of the main function. F7 is taking me to function display, and after displaying hello, it will come out. It is back to the main function. So this shows that when you call a function, the control will transfer to the function here, and again after completing of a function, it will return back to the main function or calling function. See, this function is not returning anything, so its return type is void and it is not taking any parameters. Let us write few more functions and see. I'll write a function for taking two float numbers and adding them and returning the result. So this is float add is a function name, and float x and float y. This whole line is called as prototype of a function or header of a function or a signature of a function. I will write on the body, that is implementation of a function. So here I will take one temporary variable, then z assign x plus y and return z. So this will add x and y values and store the result in z, and then it will return the value of z. So here in the main function I want to call that add function. So here also I will declare variables x assign 3.5 and comma y assign 7.9 and also z. See, one thing to observe here is this function is having variables x, y, z, and in the main function also I am taking x, y, z. Is it allowed? Yes, it is valid. This belongs to main function and these belongs to add function. So two different functions can have variables with the same names, but they will be belonging to different functions. So here I will say z assign add sending x and y. So the value of x and y from main function will be copied in x and y of add function. Then after this I will display the result z, and also I will say NL. Let us run this and see. Here I got the result, that is 10.2. Now let me debug and show you. I'll put a breakpoint here and I will run the program. See, it is on the declaration statement because I have put a breakpoint here. Now if I press F7, then it will go to the next line, that is add. And you can see here inside the watch window the values of x is what the value I have given and y is 7.9, some value what I have given. So it's not exactly the same value, that's it. So internally in the memory the value will not be represented as it is whatever it is given, because it is float type. You know how the float numbers are stored, they are stored in the form of mantissa and exponent, so it will not be exact value. Now z is not having any value and it is 0, it is having 0, we did not yet receive the result. And here inside the watch window it is showing x, y, z, 3 variables. Now I'll press F7 again. Now it has entered here and it is inside add function. So now you can see inside the watch window there are 3 variables x, y, z, and these variables belongs to add function. So here you can see that z is having some value, some garbage result is there inside z because it is not initialized. X is having the value which we have sent and y is also having the value what we have sent. Now pressing F7 will get the value of z, and we got the result of z and return z. It is on the statement return z, and the control will come back to the calling function, that is main function. So it's back into the same line. If I press F7, see, the value of z is not yet changed. It is back to this line, the value of z is not yet changed. If I press F7, now that result is brought into z variable. So z variable, you can see that it is having that result now that was sent from this function. And now it's about to display, it's on this line. Press F7, it will display here. You can see that 10.2 is displayed here. So that's it. So this is how the function calls are made and how the control transfer to the function and return backs to the calling function. We have seen this one. I'll write one more function for taking 3 numbers and finding the maximum of 3 numbers. So I will take integer type numbers and the function name I will call it as maxim and integer a comma integer b comma integer c. So it is integer b comma integer c. So it's taking 3 variables. Then the logic you know already, that if a is greater than b as well as a is greater than c, then return a. Else if b is greater than c, then return the greatest number will be b, so return b. Else return c. So I have written the logic. This is a simple logic for finding the maximum of 3 numbers. So here also in main function I'll make changes and I will declare 4 variables: integer x assign 10 comma y assign 15 and z assign 5. And also I will take one variable for getting the result. So then R assign maxim of x comma y comma z. Now the result will be in R, so I will say cout R and also NL. So from here I am calling this function maxim, and this is the maxim function, and it will take three values, whatever the x and y z and values what I am sending, that will be copied in A, B, C respectively. Then it will find out the greatest of three numbers, whether A is greater or B is greater, C is greater, whichever is greater, it will return the result. Let us run and see what value I get. So I should get value 15. Yes, I got the answer 15. So this is for finding maximum of three numbers. So in this way you can write various functions. I'll be giving you some challenges so you can solve those problems. In this video, let us talk about function overloading. What is function overloading? You can write more than one functions with the same name but a different argument list. Let us see how. I will first write main function, and here I will take some variables. Now I want to have one function called add, which will add two numbers A and B and return the result that I will take it in C. So I will write on this function integer add, which takes two integers x and integer y. Now here I don't have to declare any variable, simply I will write return x plus y. That's it, a simple function. So yes, that add function, when I call A will be copied in x and B will be copied in y, and it will add these two and return the result that comes in C. Okay, this is fine. Now I want to write one more function here, so I will declare one more variable d. Then I will say that add A comma B comma C and store the result in D. I want to add the values of A and B and whatever I got it in C, and the result should be in D. So do I have this function which is taking three integers? No, that is taking two integers. So let us write one function. Integer, what should be the name? Same name. Can I use same name? Yes. Actually, if you look at C language, there you cannot have more than one functions with the same name. But here in C++, you can have more than one functions with the same name but a different argument list. So what are the different arguments here? See, this was taking only x and y, two integers, but this is taking three integers. Yes, they are different. These two functions are different. So you can have two different functions with different parameters. So when you call this, it will be calling first function. When you call this, it will be calling second function. So C++ compiler can differentiate between two functions. So this is called as overloading of a function, that is function overloading. So we are taking extra work from same name. So the benefit here is that you don't have to think of new names every time, because that is also adding, this is also adding. So I don't have to take different name. I don't have to say add 2, add 3. I don't have to take different names. So that is the benefit we are getting. Now one more example I'll show you. I have float numbers I 2.5f and j 3.5f and k. Now k assign add I comma j. I am having add function which is taking float. Do I have it? No. Can I write such a function? Let me write here it in small space. I'll just separate it. So float add, which is taking two floats, float x and float y, and this is returning x plus y. Yes, I'll separate this also. So now I have one more function which is taking two floats. It's taking two parameters. This was also taking two parameters. These are two same functions? No, these two are different functions. These two are different functions. So how you can say these functions are different? Number of parameters are same, but the data type is same. Float, float, int, int. Here data type is same, but the number of parameters are different, 2 and this is having 3. So that's it. In C++, two functions are said to be different if they have same name but different parameter list. How the parameter list can be different? Either the data type of parameters or the number of parameters. So the benefit is that it is easy for writing the programs and you don't have to remember too many function names. When you say add, you can give just name as add. It may be taking float also, it may be taking integers also, it may be taking multiple integers also. It helps a lot to a programmer. Now I will show you some list of function declarations where you can check which is valid or invalid. Let me write few function declarations and see which are valid or invalid. So I will write on one function which name is max and it is taking 2 integers and return type is integer. Yes, I can have one more function with same name and taking float and also one more take float and return type is float. Are these two different functions? Yes, because their parameter list is different, the data type is different. Can I have a max function which is taking 3 integers and returning an integer? Yes, it is different from this one because the data type is different. It is different from this one because the number of arguments are different. 2 integers and 3 integers. Now I will write one more max function and int 2 integers but returning float. So this is matching with this one. The data types of the parameters are same and the number of parameters are also same, but return type is different. So are they different? No, this is a name conflict. It's the same function. So return type is never considered in function overloading. If the function names and parameters are exactly same but the return type is different, means they are not overloaded. It's a name conflict. It's a name conflict. Means you are redefining a same function again. So that's all about function overloading. I will show you practically how it works. Let us see function overloading here. So I will write on multiple functions. I will write on overloaded function. So here first I will write on a function for finding the sum of 2 integers. So function name is sum and it will take 2 integers a and integer b. Then there should be a return type for a function also. I'll give the return type as int. Now here a simple statement I will write on return a plus b. Just I have to add 2 numbers and return the result. So this is one function. And one more I will write float and the function name is sum and it is taking float values, 2 float values, float a and float b. Then return a plus b. So I have 2 functions with same name, that is sum and sum, but their argument list is different. So yes, these are overloaded functions. If function names are different, then they are unique function. It's not function overloading. When we say function overloading, if there are 2 functions with the same name, but their argument list must be different. I will try to write one more sum function which is taking 2 floats. Let us see what happens. Float b. Now I will write on its body. Just let us see. See here I got an error message that redefinition of sum. Already I have sum with the same signature and again I am writing one more sum function with the same signature. It's not allowed. Let us change the return type and see. I will make the return type as int. Now is it allowed or not? See, I got an error message. See, I got a complete message. Functions that differ only in their return type cannot be overloaded. Yes, it's true. We saw that. We already discussed that a return type is not considered under overloading. So anyway, I don't want floats. I want to take 3 integers, integer a, integer b, and integer c. Now here I will simply say return a plus b plus c. Now here I will call sum function by sending 2 numbers 10, 5 and L. I will call one more function sum by sending 12.5 comma 3.4 and L. Then cout, I will call one more sum function by sending three integers 10 comma 2 comma 3 and L. Let us see what happens now. See, here I am getting an error message. This is a sum function with two integers. This is the sum function with three integers. Yes, I have both the versions. But here this is a sum function with two floats. I don't have that. Don't I have that one? Yes, I have that one also. That is float is also there. Then why I am getting an error message? Call to sum is ambiguous. The reason is these values are by default taken as a double, so I have to make them as float. Now I have made them as float literals and I don't get that error now. Let us run this and see. Yeah, first I got the sum of two integers, then sum of two floats, then sum of three integers. So you have to be careful when sending the parameters, and the type of the parameters are strongly checked. This was taking float type, so you cannot send a double type which is larger than that one. So here implicitly the data type of parameters will not be changed. We have to send the proper parameters. So here these three are overloaded functions with all three same name, but the difference is in the argument list. See, here there are two arguments and here also two arguments, but their data type is different. And here we have three arguments and the data type is same, but the number of arguments are different. Because of overloaded function, it becomes very easy for us to decide the function name. Quickly we can assign the name relevant to its working. If suppose function overloading is not there in C++, then I have to give different names to these functions. So I may be giving it like this: sum underscore int 2 means it is sum of integers and that is two integers. Then I should say sum underscore float 2, say sum of two floats, and this is a function for finding the sum of int 3, that is three integers. So this is how one way I can differentiate them, or else I can say this is sum 3 and this is sum 2 and sum 1. Then I should remember what is the name of function, the one I am calling. Unless I remember the function name, I cannot call it easily. The benefit of function overloading is if the function is performing some task, then the name of that function will be relevant to that task. So this makes programming very easy and simple. It's a high relief for the programmers. So you can practice this and I will give you some challenges so you can solve those problems. Yeah, now we will learn about function templates. See, what are function templates? The functions which are generic. Generic in what sense? Means generalized. In what sense? In terms of data type. See, to understand generic functions, that is template functions, I have taken two example functions here, max, max. Oh, they are same, but the data type of these parameters are integers and these parameters are float, so they are overloaded functions. Number of parameters are same, but the data type of parameters are different. So from main function, if I call integer c assign max of 10 comma 5, then first function will be called, and float d assign max, if I say 10.5 f comma 6.9 f, then second function will be called. Depending on the parameters, these are float values, so this function will be called. These are integer values, so this function will be called. Now one thing to observe here is, you see the body of these function. The logic written is as it is, only the difference is in the data type. See, if x greater than y, return x, else return y. If x greater than y, return x, else return y. Logic is same. Why to write the same function two times when there is only a difference in the data type? So can't we write a single function combining these two functions for any data type, any type of data? Yes, I can write. So what I'll do is max T template X and template Y. Return type is also template. If X is greater than Y, return X, else return Y. Then what is this T? So here I will define template class T. So this is a definition of T which is defined as a class of type template. So now this T is a template class. So function is a template function. So I have written a same logic, but instead of data type, see int, float, int, float, int, float. So only int and float differences were there. So that I have replaced with a T. Now let us see how it works. Just think that these functions are not there. I have written just one function. Now inside main, when I say max 10, 5, this function will be called, and this T will become integer. This T will become integer. And this will work as an integer function. So it will work as first version. And when I say D assign max these values, again the same function is called, and this becomes float. This time it will become float. So this is float. So the same function work as float. So this works as this version. So the benefit of function template is that I can write down multiple functions together as a single function, where if there is a difference in the data type. So I'll just remove this. You can see it clearly. So this template function will not just work for integer or float, but it works for any data type you pass, or even if you pass the objects of your classes. So this works perfectly for any type of data. So this is one of the more powerful feature of C++, and this is confusing feature also. If you don't understand it, you cannot use it properly, or you will scare of using this type of feature. But this is more programmer friendly feature, where this was removed in other languages like Java and C#, but later they have introduced to some extent. But this is fully in the control of programmer in C++. So this is a very powerful feature. Try to use it wherever it can work for you. So try this by yourself. I have written the program. So again, even I may be showing it practically. Let us look at function template. Here I am writing one function for finding the maximum of two integers. So I am calling the function name as maxim. And I will send two arguments, a and integer b. Now in this one, just say return a greater than b, then return a, otherwise return b. So using ternary operator, conditional operator, I have written this code. This is finding the maximum of two integers. Now one more function I want, that is float maxim, same name, but it will be finding maximum of two floats, float a and float b. And here also I have to write on the same logic, return a greater than b, then return a, otherwise return b. So I have two overloaded functions, just logic is same, number of parameters are same, but the type of parameters are different. Instead of writing these two functions separately, I can write a single template function which will work for both and also for other data types. So let us define a template function. Template class T. You can give any name, not just T. T is for template, so that can be easily identified, so that we use T. Now what is the name of a function? Maxim. And what is the return type of a function? It's integer in case of int, and it is float in case of float number. So it should be a generic one. So let us take it as a T maxim. And here, what are the parameters? It may be integer or float or double, anything. So let us call them as a TA and TB. Now let us write a function. Here I will write on the same logic, return a greater than b, then return a, otherwise return b. Now I don't need these two functions. This function will work as these two different functions. I'm not getting an error, that redefinition of a function, because already integer and float I have defined. So this will be acting as a double, long, char for all other data types. But if I remove these definitions also, now that function will act as integer and float type also. So let us see, by calling this function cout maxim pass 12, 14 and endl. So this function should be called by passing integers. Now cout maxim 2.3, 1.4 and endl. Yeah, I am able to call the same function by passing integers also and by passing floats also. Just 1 minute. These are not floats. By default, these are doubles. So yes, this became doubles. These became double. So if I want to pass float only, then I should write float literal. So that is 2.3 f, 5.6 f. Now these are floats. This will work perfectly. Yeah, single function is working for all 3 types of parameters, whether they are integers or doubles or floats. See, 14, 2.3 and 5.6, it's working perfectly. So this is how we can write generic functions or function templates, we call them as. Now one more interesting thing I will show you here, that instead of 5.6 f, I'll just remove f. See, it's an error. No matching function for call to maxim. Why? What is the reason? See, this is a template t and both these are t only. When I have given one parameter as float and one parameter as double, then it is unable to judge which data type should be selected. So it's causing ambiguity. So it's unable to decide the data type. So that's why it's giving a message that no matching function call for maxim. So both these arguments must be same, because there is only one template argument that we are using t, and t is used throughout this function. So it's used here also and it's used here also. It's the same t. So if this is giving a data type to that t as integer, then this must also be an integer. If I make it as double or float, then here also I will get an error. There is no such function which is having one is integer, other one is double. This function, both the data types are same. So be careful with this one. Anyway, this is a syntax error. It's not a big problem. So I have given the same argument. So that's it. It's working perfectly. So this is how we can define template functions. I'll give you some challenges on this one, so you solve those problems and you can practice this one by yourself.
Yeah, in this video we'll learn about default arguments. So for explaining that, I have taken 2 functions here. Both these function names are add, but 2 integers and 3 integers. So yes, they are overloaded function with the same name and different number of arguments. What they are doing? They are adding numbers. This is adding 2 numbers, this is adding 3 numbers. So let me write main function. Main. I'm not writing void in everything. So just I will say integer c assign add 2, 5. So which function it will call? It will call the first function. Now c assign add 2, 5, 8. Which function it will call? It will call second function. So just the number of parameters are different, and here their working is little bit different. But I'll show you one more thing. Can't I say this add and say 2, 5, 0? Which function will be called? First. But what results it will be giving? Same as first function. Same as this one, 2, 5, because the third argument I made it as 0. So if I am ready to pass the third argument as 0, then I don't need the first function. Come to the point. Can I combine these 2 functions and write a single function? Let us see. Integer add int x, int y, int z assigned with 0, and return x plus y plus z. Now imagine I don't have these functions. Then what I have done here,
I have assigned some default value to this argument within the argument list only and said that z is 0. So if I call add, same function will be called. So this 2 goes into x and 5 goes into y and z will become 0 because I am not passing it. Second time 258, 258, z will take the value 8. So this means this argument, this parameter becomes optional. If you don't pass it here, it will take 0. If you pass it, then it will take that argument. So even when I pass the 0, already it was 0 only, so it will take 0 and I get the result. So it means I have combined these two functions, you see, the one which is taking 2 arguments, the one which is taking 3 arguments. So a single function can work as 2 argument function also, 3 argument function also. So I have combined these two overloaded function and written one function. So this is called as a default argument. So assigning some default values to the argument is default argument function, and the benefit of default argument is you can combine the overloaded function and write one single function. So this is a very powerful feature of C++ and it is friendly for the programmer. He can combine various overloaded functions and write them as a single function with the help of default arguments. Now one important thing about this one, suppose if you have one function, let us say function fun, and you are taking some arguments a, b, c and d, and if you want to make default, then you should make default this one or this one. You cannot make this as default and skip this one, make this as mandatory. So whatever the default arguments are, you can make this as default, and this means you should start making the default argument from right towards left without skipping any. I will show you these things practically. Let us check it there. Let us see default arguments in functions. I want to write a function for finding sum of two integers. So I will take a function name as sum and integer a comma integer b. Now here I will say return a plus b. I want to modify this function for now. Now this function can take two integers and find out the sum of those. Let us call this one cout sum 10 comma 5. Just now we have seen this type of function. Now I want to write one more function with the 3 parameters finding the sum of 3 numbers. So I will declare a variable c here itself, and I will add these 3 numbers and send. Now this function is gone. I don't have a function which takes 2 parameters. So see here, no matching function for call to sum. It's not found. But this is available. Cout sum 12 comma 13 comma 14. I have passed 3 parameters. So this is valid, and this function became invalid. This is valid because there are 3 arguments. Now what I'll do here is the last argument I'll make it as 0. So this is optional. Now this is not an error. If I pass 2 arguments, this 10 goes into A and 5 goes into B, and by default C will be 0. And when this A, B, C are added, the value of C is 0. So I'll get the exact result of 10 plus 5. So a single function will work as a 2 different function, one with the 2 arguments and one with the 3 arguments. And these arguments called as default arguments. The benefit of default argument is we can define overloaded functions by writing a single function. Now let me write one function for finding maximum of 3 numbers. Let us see. Int max integer a comma integer b comma integer c. So this is taking 3 arguments, and here I will check return if a is greater than b as well as a is greater than c, then return a. Otherwise, if b is greater than c, return b, otherwise return C. So using ternary operators, I have written this function just in a single line. See, this is the conditional statement, and this is if part, and this is else part. If I want, I can put it in brackets also. This is the else part. This else part is again having a conditional statement, and this is the if part, and this is the else part. Now let us call this function, that is max, by passing some arguments 10, 13, 12. Let us see what is the result it will return. It should return 13. So yes, answer is 13. I got the answer. Now I want to make one of the argument as default. So I'll make C as default, and here I will pass just two arguments, that is 10 and 13. Let us see what will be the result. Again it is working. So it's working for just two parameters also, and it is working for three parameters. Let me check with value 15. I should get the result 15. Yes. So it's working for two arguments also, it's working for three arguments also, because the last argument is optional and it is having default. I will make first argument also as default. This is 0. Then only one argument is also allowed. So let me remove all these and just take 10 and call this one. Yeah, it is not an error. It is able to call that function. So it is sending the value 10. So this is working. Even if I send a single parameter also, it's working. I will give this also as 0, A also as 0, and I will not pass any argument. Yes, still it is valid. So this single function is acting as four different functions. One is max without any arguments, and one is max with one argument, that is 10, and max with two arguments. I'll pass two arguments 10, 13, and one more max with three arguments, that is 10, 13, 15. So for all these function calls, the same function will be called, and it means it is just like an overloaded function. So you can see the complete program here. So the single function is acting as four different overloaded functions, that is 0 argument, 1 argument, 2 argument, and 3 argument. So it works, it's not an error, and it will show different results. So the values are 0, 10, 13, 15. So I got the perfect result for all four function calls. First time when I am not passing anything, so 0 is the greatest number here. When I pass 10, so 10 is the greatest number, and so on. Now one more thing I'll show you here, that if I remove this default argument, then what happens? See, it's an error, missing default argument on parameter B. So parameter B, we have missed this one, so we must give default argument to this one. If you want, you can skip this one. It means if you want to fill default arguments to the parameters, you should fill them from the right hand side, not from left hand side, and without skipping any argument. See, I have removed the default argument, so this function call became a invalid function. I'll make this also as default argument. Now everything is perfect. So default argument feature is very useful feature in C++. I'll give you some exercises. You have to solve those challenges. So by that time you try this on your computer.
Let us talk about parameter passing methods in this video. We have already learned about functions, how to write the functions and how to call the functions. We learned that parameters are taken by function as input, and the functions will process and perform some specific task, and they return some result. So what are the methods a function can take the parameters? So we'll learn about this. So there are three methods a function can take parameters. These are the three methods supported in C++. If you know about C language, there were only two methods, that is pass by value and pass by address. But in C++ there are three methods: pass by value, pass by address, and pass by reference.
So this actually we can also call it as call by value, call by address and call by reference also. It's the one and the same thing. So by taking one single example, I'll explain you the differences between these three methods, how they work. And once you know about these methods, so you can use them based on their requirement, and whichever is suitable you can use that. So here I have written one program to demonstrate all these three parameter passing methods. So let us see. Let us understand the code first, then we look at all the parameter passing methods one by one. See here inside the main function I have two variables x and y. They are having some values 10 and 20. Then I am calling swap function here. Swap means it will interchange the values of x and y. So y will become 10 and x will become 20. That 20 will come here and 10 will go there. That is the purpose. For that purpose I have written this function. Then after that I am trying to display x and y. So what I am expecting is 20 and 10 should be displayed, because after swapping the value should change. Now what the function I have written, let us look at this. This function swap int a int b. So these values will be passed in this one. Then there is a temporary variable, and here is the logic for swapping the values of a and b. Now this parameter passing method is actually call by value. So once I explain, then I can make you understand what does it mean by call by value. Let us run this and see really it will swap two values or not. Let us look at the execution of this one. You know well that the memory is divided into three sections. One is a code section in which this machine code of this program is residing, and now let us start the execution. The program will start from main. This is the entry point of a program. So the very first line says that I need two variables x and y to store some numbers. So inside the stack a block of memory is allocated for x having value 10 and y having value 20. And this block belongs to main function. We call this as activation record. Now next swap function is called. The moment the swap function is called, inside the parameters it says that it needs a, b, and also inside that there is a variable temp. So block of memory is allocated for swap function, and it will have variable a, b, and temp. Now as this function is called, the value of x is copied in a and the y is copied in b. So 10 is copied here and 20 is copied here, and this is for swap function. Now let us see what is happening here. The value of a and b are interchanged. So temp assign a value. So 10 will be copied in temp. Then a assign b value. So b value is stored in a. So this becomes 20. Then b assign temp. So b will contain the value of temp. So 10 is stored here. So yes, they are swapped. Now this is the last line. The moment the function ends, you know well that once the function ends, its activation record or the block of memory inside the stack will be deleted. So this will be gone. I will not mark it, just I will show it as deleted. Okay, this is deleted. Now the control come back to the main function. Now it will print x and y. So what are the values of x and y? 10 and 20. Oh, they are not swapped. This is 10 as it is, this is 20 as it is. They are not swapped. Yes. So this is call by value method. In this method, the values of these x and y, they are copied in this one. And swapping of these variables is done, not the actual parameters. So that's the point here. In call by value method, the value of the parameters is passed to a function. So these parameters, we call them as actual parameters, and these parameters we call them as formal parameters. So just to differentiate, these are also parameter, those are also parameter. To differentiate, we say these are actual and that are formal. So the value of actual parameter is copied in formal parameters, and if any changes are done inside the formal parameters, will not change the actual parameters. So if you want the call by value mechanism to modify actual parameters, it cannot do that. Then when do you use call by value mechanism? If you want a function to just take the values and perform the operation and return the result, then you use call by value. This function is not returning anything, and call by value method is not suitable for swap function. For other purpose, you can use call by value. So in practice, we will be looking at call by value methods also. While writing further programs, I'll show you where call by value method is useful. So we have finished with the call by value. So I repeat the points once again, that if any changes are done to formal parameters, that will not reflect in actual parameters. You can see that the activation record of main is different and the activation record of swap is different, and it is making changes in its own variable. So it is not modifying main's variables. That's all. This is call by value. Let us look at parameter passing method for call by value, pass by value. I will declare some variables. Now, as I have already shown you, I have used a swap function. So let us write a swap function here. Swap function which takes parameters A and B. Now here I write down the code for swapping two numbers, that is A and B. A temporary variable, then a temporary variable assign A, then A assign B, then B assign a temporary variable. Then after swapping, then from main function I will call this swap function by passing X and Y. So when I write just X and Y, the values of X and Y will be copied in this A and B, and it will swap the number. So who will get swapped? The variables A and B values will get swapped. Actual parameters that are X and Y, they will not get modified. So after this, I will display the values of X and Y. So what values I should get? I will get the same values 10 and 20 because these values will not be swapped. So I'll do one thing, I will display here A and B also, so you can know what are the values of A and B. And before swapping also I will display their values. So first I will display the values and then swap them and again display the values, and let us run this and see. Yeah, first values are 10 and 20, that is in the beginning, here they are displayed. Then 20 and 10, so the values are changed. And finally it is displaying the values of X and Y, they remain same, that is 10 and 20 only, they are not swapped. So in call by value mechanism, the values of the formal parameters, if they are modified, they will not reflect into actual parameters. Let us debug this program and see. So here I'll add a breakpoint and let us run the program. Now next line, when I move, the value of X and Y are initialized, that is X is 10 and Y is 20. X is 10 and Y is 20. So you can see that they are having these values. Now let us move further. Now this has entered into swap function and the values of A and B are 10 and 20. Yes, move ahead. Now the values are printed 10 and 20. Now temp value, this is not yet completed, so it is garbage. If I continue, if I see the values of A, B and 10, A became 20 and B is still 10 only and temp was having 10. Now if values of A and B are displayed, so they are changed to 20 and 10, the values are swapped. So whose values are swapped? This local variable values are swapped. Actual X and Y are not changed. These X and Y, they will remain same. So now we are not inside this function, so I cannot see these values. Now we are back to the main function. So the values of X and Y remain same, 10 and 20 only. They are not changed. Even though in the swap function we have changed the values, so the values of A and B are swapped, not the actual parameters. So that's it. So this is our call by value. So when you know that we don't have to modify the values, just you want to send something to a function so that function returns back some result, then call by value mechanism is useful. Now already you have seen call by value method. Now I will show you what is call by address. In call by address, I have same code here. Now I'll make some modification to make this code for call by address. See, main function is having X and Y variables and it is sending them to swap function. So it will not send the values. Now it will send the addresses. Ampersand means the address of a variable. So it will send the addresses of these variables to swap function. Then who can take addresses? You know well that the variables who store addresses, which variables use for storing addresses? Yes, pointer variables.
So these must be pointers. So I should declare them with star to make them as pointers. Now the formal parameters are pointers, actual parameters are addresses of variables. Then inside this one, for swapping, I will not be swapping these addresses, but I will be swapping the data. So A is a pointer to X and B is a pointer to Y. So when I say A, it's the address of X. But when I say star A, the data of X. So I should write star here, star A, that is dereference the pointer. Now this code is for call by address. So I have made changes so you can see how the changes are made. This is call by address. Now let us see the working of this program. Now really that swap function will modify the values from 1020 to 2010. It will swap them. This swap function can access actual parameters and it can modify them. Let us see the working, how it executes. Let us start main function entry point. So first the variables X and Y are created. So X is created in the memory and Y is also created in the memory inside the stack. So let us say the address of this is 200 and 201 and this is 210 and 211. Just randomly I am giving the addresses, though they are side by side in the memory. Now this is the activation record of main function. This is about main. Now next is swap function is called. Addresses of X and Y, that is 200 and 210, are sent here. So who are A and B and temp? These are the variables of swap. So the activation record for swap is also created. This is for swap and it will have the variables A, B and temp. Now what is copied in A? What is being passed from here? Ampersand. So address of A is copied here, that is 200. It means this is a pointer to this one. So 210, it's a pointer to this one. Temp is a normal data variable. Now the function is called. Already we have seen that the activation records are created. Now let us see next what happens. See the first line is a temp assign star A. In temp star A is 200, star A is a 10. 10 is copied here. Then star A assigns star B. Star A means asterisk A. Here asterisk B is copied. So that is 20. So this becomes 20. Then star B assigned temp. Asterisk B assigned temp. So this is star B. This is B and this is star B. So temp is copied here. So you can see that this function is accessing the variables of main function. Yes, we know that one function cannot access the variables of another function, but it is possible through pointers. Through pointers it is possible. So this is called by address mechanism. So pointer gives a power to a function to access the parameters of a calling function. So that function is accessing X and Y. Now end of this function, come back, see out X, Y. So what's the value in X? 20. And what's the value in Y? 10. Yes, they are changed. From 10 it became 20, from 20 it became 10. So their values has changed. Who has changed these values? Swap function. So that's it. This is called by address. If you want any function to modify the actual parameters, then you can go for call by address mechanism. And one more thing, it's not necessary that both the variables must be called by address only. One variable called by value, one variable called by address, or one variable called by reference. You can take it like this also. It all depends on your requirement. So further we will see where call by addresses are useful. Next is call by reference. See, if you remember, references are a nickname to a variable, existing variable. So let us look at call by reference mechanism. See, this code is for call by value only, as it is call by value code only. You can read it once. It's same. Now I will make changes in this one to make it as a code for call by reference. Let us see the changes. And the changes are very minor. Very minor changes are there. See, at the place of call, we don't write anything. You remember in call by address, we were writing ampersand here, but we don't write anything in call by reference. And here in call by address, we were writing stars, but in call by reference, we write ampersands here. And in call by address, we were filling stars here. No stars, nothing, as it is.
So it's more like the syntax, the way of writing is the same as call by value only the change is at the parameters we write ampersands and they become references. So the syntax is very simple, more like call by value only. But now this mechanism can modify the actual parameters. It works similar to call by address. So unlike call by value where the changes cannot be done in actual parameters, but in call by reference changes can be done in this parameter. So let us see how it works. I'll show the execution. The main function start. The moment main function starts, the variables are created for main, and this is x having value 10 and y having value 20. This is for main. Now swap function is called, this function is called, and this is having three variables, that is a, b and temp. But what are a and b? They are not separate variable, they are references to x. So this itself is a and this itself is b, and it is having temp also. So how it is possible that that function can directly access the variables of this function? It's not possible. It's not possible. Then how it happens? See, we already know that one function cannot access the variables of another function at all. But here we are saying that that swap function will call this as a and this as b. How it is possible? So when you use a call by reference mechanism, watch carefully what happens. When the machine code is generated, machine code will not be generated like this, but the machine code looks like this. Main function, and the main function is having its code, and in this place where the swap function is called, the machine code of swap function will be copied. So this piece of code is for swap function. So this means that whenever you use call by reference mechanism, it will not generate separate piece of machine code. It will copy the machine code at the place of function call. So this swap is not a separate function. It's a part of main function only. Yes, exactly. It's a part of main function. So that same part of main function is calling this as a and this as b. So there is no harm. So there is no activation record created, and actually function is not called. There is no function at all in machine code. In source code we wrote a function, but in machine code there is no function. Then what about this temp? Temp will also be created for time being inside the activation record of main function only, and this will be there as long as this piece of swap code is executing. Then it will access temp assign a, assign b and b assign temp. So the values are interchanged. This becomes 20 and this becomes 10 with the help of this temp. That's it. So this is the greatness of C++. That is, no other language is having this type of feature, that basically whenever you write a separate function, a separate piece of machine code will be generated. But in C++, that piece of machine code can be replaced at the place of function call. So when do you use a call by reference? Whenever you want the actual parameters should be modified. This is one. Second point, you should not write any complex logic inside the function if you are using call by reference. Even if one parameter is called by reference, you should be careful. Reason, this code has to be copied at this place wherever the function is called. If you call multiple times, then multiple times copying will be done. So when the code is being copied, this is the job of a compiler to copy the code there. So if the code is complex, it may not be able to do it perfectly. So usually you find warnings if you are using loops inside this type of function. When you use call by reference, avoid using loop. 1 or 2 lines of statement is sufficient. Now one more thing, I can tell you one more point here, that if the piece of machine code of a function is copied at the place of function call like this, then such functions are called as inline functions in C++. When you use a call by reference, the function automatically becomes inline function. So we also have a topic called inline functions. Separately we'll study about them. So these are the 3 parameter passing methods. I will take the same example and show you practically how they are different from one another, and also you can practice this one, and slowly we'll be using them in our programming. You will be getting more and more clear idea where to use them. Let us see call by address. I have a same program that is for swapping 2 numbers, and already we have seen that in call by value, values will not be swapped. So here for call by address, I should pass address of these actual parameters. Actual values are x and y, so I'll send addresses. Now I got a message that there is no matching function. So here I must write down pointers. So these are pointers, a and b are pointers, and these are pointers, so I should derefer them by using asterisks. So this is the change in the syntax. Now here, after swapping the values, if I display the values will be swapped. So here I am displaying the values, and also L. Let us run this program and see. See, here I am passing x and y values by address, and these are the pointers which will directly modify these x and y values. So these x and y values will be swapped. When I display, I'll get 20, 10. So here I got the values, that is 20 and 10. These two values are displayed here. So that's it. This is called by address, where the formal parameters are pointers and the formal parameters can indirectly modify the actual parameters. Now next, let us look at call by reference. So in call by reference, I'll just modify the same code. See how simple call by reference is. I will remove this ampersands, and here I will remove pointers and I will make them as references. Then here I don't have to write asterisks, so asterisks are removed. Now these a and b will be referring to this x and y. So I'll show you here by displaying addresses of a and b. Ampersand a, that is address of a, then ampersand b, the address of b. And here, before displaying their values, I will display address of x and y, ampersand x and ampersand y. You can see that the addresses of x and y and here a and b will be same, because these a and b are nothing but x and y only. See here, this is the address of a and the address of b, and this is the address of x and address of y. The y address and the b value is same, and here the value of a and x is same, so their addresses are same. So it means it's the same variable, so it's not creating any other variable separately. A refers to the same thing. So what happens here is that though we have written it as a function, but it will not be called like a function. This machine code of the swap function will be pasted at this place, and in our program it remains as a function only, but the machine code that we get will not be having two different modules, it will be having a single module. The machine code that we will get will not be having two pieces of function, there will be a single piece of function. So finally I can say that call by value should be used when you don't want the function to modify anything, just it has to compute and return the result. Call by address you can use when you want the function to modify actual parameters. And call by reference is also used for same purpose, but it can be used only for simple functions. If inside this call by reference function, I'll just write something here and show you. Integer I as 0, I less than 10 and I plus plus, then I will just write something here, cout I. So if I write any complex code like this, loops or something, this function will no longer be using call by reference, it may become call by address, automatically compiler will change it. So therefore we should not write any complex code inside the functions which are using call by reference. So that's all about parameter passing methods.
Let us look at a type of function, that is return by address. So function can also return addresses. Function can take parameters as addresses, so they are called as call by address type of parameter passing, and also function can return an address also. Let us see some example function which returns an address. So I will write one function called as fun, and it takes some size as a parameter. Then what it does, I will write the return type afterwards, but what it does is it will take one pointer and create an array of that size. So where the memory is allocated. When a new is used here, so the memory is created in heap. So this is creating an array inside heap, and p is a pointer to that memory. So let us take, for example, if the size is 5, so array of size 5 is created in the heaps, and p is a pointer to this one. So this belongs to function fun. Now I will add some code here. So what I'll do is I will fill those values from 1 to 5. For integer I assign 0, I is less than size, and I plus plus. So this will be taking me through all these elements of a array P. Then P of I will assign I plus 1, means whatever the value of I is plus 1. So P of 0 as 1, P of 1 as 2, P of 2 as 3, and 4 and 5. So this will fill the elements with natural numbers from 1 to 5. Then what the function has done, created an array and fill the elements. Now return P. What is P? P is a pointer to an array of type integer. So this is a pointer of type integer. So that's it. This function is useful for creating an array and initializing all the elements from 1 through whatever the size you have mentioned, and then it will return the pointer to that one. So if I call this from main function, then I will take a pointer here, ptr, and I will call the function fun with the size 5. So what happens, this function will create an array of size 5 and initialize some elements there and returns the pointer. So this main is having a pointer ptr, so it will be pointing on this one. Is it allowed like this? Yes. See, this function has created some memory in the heap and it has not deleted, so the heap memory will be as it is, and it is handing over that address to the main function. So ptr will be a pointer to that one. So if you have any work related to heap memory, then those function can return the address of that heap memory, and it will be useful for the calling function. Main is calling it and the main can access that memory. Now finally we saw that a function can also return an address. So this is a return by address method. So function can take the addresses also and return the addresses also. So I have given you an example where it may be useful. So this is one of the example. So we will try this practically and we will see this one. Now let us see return by address. We have seen that a function can return the address also. So for that I will write one function which returns a pointer of type integer, and here I will declare some variable x with some value, and here I'll write return address of x. Let us see what happens. I got a warning here that address of stack memory associated with the local variable x returned. So the problem here is that I cannot return the address of local variables. Already I said that once the function ends, this variable x will be lost from the memory, deallocated from the memory. So we should not use these local variables. So then which type of addresses we can return? We can return the address of heap memory. So if I am allocating any heap memory here, if I am allocating a heap memory here, like I will take a pointer and I will say new integer of size, suppose 5. And then I will also initialize this memory integer I assign 0, I is less than 5, and I plus plus. So what I will do is I will store values, that is multiples of 5 I will store it. P of I assign with 5 into I. Then finally I will say return P. So using this pointer it will create heap memory of size 5 integers, and it will initialize this array of size with the multiples of 5, 5 into 0, 5 into 1 and so on, and the values will be initialized, and it will return this address that is allocated in heap. So here inside the main function I will declare one pointer q, and I will call the function, and that function will return the address of this heap memory. Here in the main function I will declare a pointer with name q, and I will call this function. So that function will allocate the memory in heap with the name p, and it will return p. So the address of that pointer will be stored here in q, and here I will display all these elements once, and let us see. For integer I assign 0, I is less than 5, I plus plus, then I will say cout q of I, then also NL. Let us run this and see. Yeah, it is displaying the values. First value 0, then 5, then 10, then 15 and 20, because there are 5 values. Now here I would like to show you what is the address there in P. So I will say cout P,
and NL. Let us see what is the address in Q. Cout Q and NL. See, this P is creating memory in heap and it is returning the address. So that address I am displaying here, and then it is returning the address. Then here inside this function, that address is taken in Q, and let us print this Q and see what happens. Oh, the address that is there in P and the address that is there in Q both are same. So it means Q is pointing on to the same memory. So as heap memory is global to the program, which can be accessed from any part of a program, provided address of that memory must be there. So this function is sharing the address of this memory to the main function, and the pointer Q is accessing that memory. So that's it. This is a call by address mechanism. Oh, sorry. So that's it. This is return by address. So at some places we need the returning of value by address. Now let us look at return by reference. For that I will write on the function which returns a reference, and here I will have some local variable and I will say return x, that is return by reference. Now let us see what happens. Again I got the same warning that reference to stack memory associated with local variable x return. So I cannot return the reference of local variable. Then even reference is not a pointer to point on some heap memory. Then where it is useful? See, suppose I have a local variable in main function having value 10 and its name is a. Then I will call the function fun and I will pass a. And let us make this function fun take a reference variable x instead of having local variable declared. Now what I am doing here is I am just taking this value of a as reference and simply returning, nothing else. I'm not doing anything, no modifications at all. Then when it is returned by reference, this x will come back here and the entire function becomes a reference. So whose reference it is? It's a reference of local variable of main. Main is having a is sent to this x, and x is a reference to same a, and then it returns. So this becomes a. This becomes a. So you can see this, it is taking a parameter as reference and returning same thing as reference. So here this becomes a. So it means, can I assign something to a here? Let us see. I will display this value of a. So what I should get? I should get the value as 25. Yeah, it's not an error. So I can write function call on the left hand side of assignment. So it works as L value. Let us run this. Yeah, value 25 is stored in a. So it's working. That's it. This is return by reference. So this is useful at some places. We will see where it is useful. Both return by address and return by reference, I will use it in some examples. This was just the introduction.
Let us look at return by reference. So I already have some sample piece of code, a very small function. Just look at this one. See, I have a main function and one variable x having value 10, and I am calling function fun by passing x. So this function is taking an integer variable. So the value of x will be copied in this one. So this is x having value 10. So this x is copied here. So this is a, and in this value 10 will be copied, and print a. So 10 will appear on the screen. This line will print a on the screen and return a. So that return value, I'm not taking it anywhere. Okay, it's not necessary that you take the return value of every function. This is call by value. Okay, I have not yet come to this one. Just I am showing you the code first. First I am showing you the working of this one. Then we will make it as return by reference. Let us see. Now you might have seen this one, that I can write y assigned some function call. So we know one thing, that when the function returns something, that return value we can take it in some variable. Yes, return result we can take it in some variable. So function always comes on the right hand side of assignment. We don't write them on the left hand side. We know this. On the left hand side we take some variable so that it takes the return result. But now I'll make changes in this one and see what happens. Now from here I am sending x, but this a is not a separate variable, it's a reference to this x. So now what happens is, there is no separate a, but this itself is a. This itself is a. So this is called by reference. Okay, here up to it's okay. Then C out A, what it will display? A is what? X only. So it will display 10. Then return A. Here I will write ampersand.
It returns not the value of A. What is A? X only, 10. It will not return 10. It will return the reference. Reference of what? Same X. So when it returns here, this function
becomes nothing but X only. This becomes X. So this is nothing but X now. We have sent it X to this one. It has used, that is printed something, and return A. So what is A? Reference to X. So it is returning X only. So this whole thing become X only. So I can write here assign 25. So what happens here? This will become 25.
So now you can see an amazing thing here, that a function is written on the left hand side and a function is acting as a reference of this variable X. This whole thing become X.
Now after this line, if I say C out X, what value will be printed? 25 will be printed. So this is one of the amazing feature of C++, that on the left hand side of assignment, that is L value, you can make the function as L value. Mostly we make the functions as R values, but you can make it as L value also with the help of return by reference. And this is useful at some places. We will look at them whenever we come across this. We will discuss more about them whenever we are using them. Try this program by yourself and check, and even I will show you. Let us look at difference between global and local variables. This is a common terminology. These are the commonly used terms in programming, global variables and local variables. So for that I have a sample piece of code here. Let us read the code and understand it first, then I can show you the differences between them. See, this is a main function, and is it having any variables? No, there is no variable here, but G assign 15. So where is G? G is here. It's outside the function. It's neither in fun nor in main function. See, these are two different functions I have. It's not any one of these, so it is separate. Can you have a variable outside all the functions? Yes, such variables are called as global variable. They are accessible where? They are accessible in all the functions of your program. So they are accessible in function fun also, and they are accessible in function main also. So they can be used anywhere. These are global variables. Then if I continue reading this one, G assign 15. So this variable is becoming 15. Okay, it is 15 now. Then call function fun. Int A. What is this variable? This belongs to function fun, and it is a local variable. So we already know about them, that where those variables are allocated in the main memory whenever the function is called, and deallocated whenever the function terminates. So this variable is local to a function. Let us continue. G assign G plus A, 5 is added to this one, so this becomes 20. Okay, then C out G, 20 is displayed. Then function ends, come back G plus plus, so this becomes 21, and here 21 is printed. Doing nothing, just as a sample code I have written to show you that this variable can be accessed in any one of these functions. So this is a global variable and this is a local variable. A variable inside the function is local and the variable outside all the functions is global. And even if I declare some variable here X, then this is local to main function. This is also a local variable. So the variables inside the functions are local, the variables outside the functions are global. Now let us know their differences. First, local variables. They are not accessible in other function. They belong to that function in which they are declared. First point. Then second point, they remain in the memory as long as the function is running. Once the function ends, they are terminated. 2 points. Then what about the global variable? Global variable are accessible in all the functions of a program. That's the first thing. Then the second thing, how long they are there? As long as the program is running, they are there in the memory. They are there in the memory. Now let us see, we know this memory area, and this we call it as code section, and this we call it as stack, and this we call it as heap. Now if I use those two functions, function fun and function main, then how this code will work?
Let us see. First thing, where the global variable, where the memory for the global variable is created, where do you think? Is it inside the stack or inside the heap? If it is inside the stack, then does it belong to function fun or main function? No. Memory for those global variable is allocated inside the code section. So actually, not here, we show it like this. A small piece of memory is belonging to the code section only, which is meant for keeping global variables. So we show it like this. And the initial size is 0. So code section is from here to here. This whole thing is a code section. So instead of creating any confusion, to make it more clear, I will show it here. I'll show it here inside the code section. Okay. If you refer books or if you check somewhere online, you can find some diagrams where above the code section, there's a small section. That is a part of code section only, subsection of code section. That is for global variables. So, but I am showing it directly here. This is easy for remembering and understanding it. Avoid all confusions. That is created in code section. That's it. Well, whenever you say I want to run the program gets loaded here. At loading time only they will get the memory. Now let me continue execution. First of all, main function is called. Main function is having one dummy variable. I have taken it just for the sake of this diagram. I have taken this variable. So for main, x is created, having value 10. This is for main. The next is g assign 15. So main can access this one and it will become 15. Then function fun is called. This function fun is called. Then it is having its own variable, function fun a. And this is having value 5. Yes. Next line is g assign g plus a. So this becomes 15 plus 5, that is 20. So this becomes 20. See, function fun is also accessing this one. Then c out g, so the value 20 is displayed. Now function ends, all lines end. Once the function ends, its memory is deallocated. G is still there. See, you can see how long the variable a was there in the memory as long as this function was running. But what about g? It's there always. I don't have to show you the remaining part now. So this is the difference between global and local variable. I have given you the points and I have also shown you where they are created inside the main memory. So we use global variables a lot of times. Declaring global variables is a common practice of programmers. They use it when they don't find a right place for a variable. They think that it should be accessible by most of the functions. Then you make it as global. So let us try this and see. Now let us look at local and global variables. I will take one function fun. Here inside this I will take one local variable a with value 10. Now this is a local variable that is useful only inside this function. I can say a++ or I can say cout a. This is accessible only here. Can I access that same function inside main if I say a? See, there is no a declared here inside main function. So there is no a declared inside main function. So I am getting an error message that is use of undeclared identifier a. When a variable is available in some function, it's accessible only there. It means the variables have local scope in C++. I will declare one global variable, integer g, assign 5. Now this should be accessible everywhere, which is declared outside. Now inside main function, can I say cout g? Yes, that value of g can be accessed here. Can I access that same variable g in function fun also? Yes, we can access that in function fun also. See, there are no error messages here. So it means this g is accessible inside function fun as well as inside function main. Here I will say g++. I will modify the value of g. G is 5, so it becomes 6, and here it should display 6. And what about main function? See, inside main function I will call function fun. Then again I will display value of g. Now if you see here, this is cout g. First the value of g, that is 5, is displayed. Then it will call the function fun. Function fun will have variable a and g. A is increase and g is increase. It should print 11 and 6. Then when the function return back again in the main function, it should display 6. Let us see what are the results we will get. We should get 5 and 11, 6, and then again 6. Yeah. First the value from the main function, then the values are printed from function fun, then again the value from function main. I'll do one thing, I'll remove these things and I will also remove this a. Now this is function is having just a g. So g is modified by function fun, and here let us display g before and after calling function fun, and from here also I will change. Now just in main function I will print the value of g before calling function fun and after calling function fun. So g should be changed to 6 because the function fun is changing the value of g. So this is the only work I am doing inside function fun. Let us run. Yeah, I got the values as 5 and 6. See, these are the only two couts I have, which is printing 5 and then this is printing 6. So this shows that variable g is accessible in all the functions. So these are global and local variables. Now let us see one more thing. Inside function fun, I will declare one more variable called g and whose value is 10. Now you can see that the color of this g has changed. It was green to show that this is global variable. Here it is green. Now if I say g++, then what happens? Let us see. Now if you see function fun, it is having a local variable g also and global variable name is also g. When we say g++, which variable it will increment? It will increment local variable. So when the compiler will look for the declaration of variable in the nearest scope, so this is the nearest scope. Let us run the program. Yes, the global variable 5 is not modified by this function fun. Main function have displayed g before and after calling function fun, so it has not modified the global variable. Now, one more thing I'll show you. Here I will have a block level scope, and inside this block I will have one more variable integer g assign 0, and I will say g++, and also I will say cout g and l. Now here I will display cout g. Can you figure out which variable we are referring to? See, here I have a local variable g, but again a block is there. Inside that again g is declared whose value is 0, and g++, which g will increment? This local g will increment and the value will be 1. And when it comes out of this block, then the value of g, which g is accessible here, which is outside this block, outside the block. So that value is 10 and it remains 10 only, and the 10 value is displayed. Let us run this. See, first the function main is printing this g, that is 5, and then 1 is displayed, so that is this one, this variable g. And then this variable g is 10, so this is referring to this one, because this is within this block only and g is created and destroyed. So that's all. So variables in C++ have block level scope. So in this block, this g belongs to this block only, and this g belongs to this outer block, and as inside this block there is one more g available, so this outside g is not accessible, and this is a global variable g. Let us look at what are the levels of scope C++ supports. I have three variables: x, that is global variable, and this is local to the main function, and this is local within this block. So C++ have block level scope. Now inside this block, if I print cout x, then which value will be printed? So it will print the nearest value of x, that is 30. And outside the block, if I say cout x, then which x will be printed? It will be printing the value that is in its nearest scope. So this variable was inside this block. Now cout is outside the block. So when it look out, so it will find this variable x. So it will display this value 20. So if I run this program, I will get the value 30 and then 20, and inside the main function this x will never be accessible, that is 10 cannot be accessible inside main function. Whenever I say x, this will be accessing this local variable x, but if at all I want to access this global variable x, then I should say cout scope resolution x. So this will be accessing that global x, that you can see that the color of x has changed to green. Now let us run this and see. The values that I should get are first here 30, then 20, then here 10. Here 30, 20 and 10, these are the values that I got from this one.
So C++ have block level scope.
Let us look at static variables. This is little confusing, so I will make it very easy for you. Just listen it very carefully. I have already covered local and global variables. So based on that, with the help of that, I'll explain you static variables. See, here I have an example program. Inside this, I have one global variable, that is v, which is having value 0. Then function is there, which is having a local variable 5, and it is doing v++ and displaying a and v. And from main function, it is calling function fun for 3 times. Now let us see how it works, what will be the output. We know well about the global variables. First I will show you the working, then I will show you what is static variable. So main is not having anything, just it is calling function fun. Main is not doing any work at all apart from calling this function. So let us see. The moment I say I want to run, this is loaded inside the code section. So the machine code is loaded in the code section. Then also variable v is created. You know well that these global variables are created inside code section at loading time before the execution of a program. Now let me execute and show you. I am using global variable again. Just a minor change, I'll make you understand static variable. Just follow this carefully. Let us see the execution. Main function starts. So there is nothing inside main function. So a dummy activation record I am taking. There is no variable, so no memory at all. Then function fun is called. Function fun activation record is created. What is the variable inside this one? A. And what is the value in this one? 5. Then v++. This v becomes 1. This v becomes 1. Then print a and v. A is what? 5 and v is what? 1. So instead of showing here, I will show here. So 5 and 1. A is 5 and v is 1 in the first call. This is displayed. And once the function ends, this activation record is deleted. Then it comes back to the main function. And what is the next line? Again the function call. Again the function is called. So activation record is created. A is created. What is the value of A in 5? Then v++, v becomes 2. And print a comma v. A is what? 5 only. And v is how much now? 2, as it's a global variable. Now once the function ends, again the activation record is deleted. Now you know when I call it again, 5 comma 3 will be printed. Now we can understand what are static variables. Listen. This is local variable for function fun. It is created and destroyed whenever the function is called. This is a global variable which is remaining there throughout the program inside the code section, and both these functions can access it. But here in my example, only function fun is accessing, main is not accessing. It's no problem. It's not mandatory that every function should access it. Now, this is a global variable. Who can access? Any function can access. How long it will be there? As long as the program is running. I want this variable inside this one. Int v assign 0. If you bring that variable here, it's not global. It became local. It became local. Yes. No. I want that to be just like a global. What does it mean by just like global? There are 2 points about global. It can be accessible everywhere and it will remain always in the memory. Which one you want? I want it to remain always in the memory like this. I don't want it to be accessible by all the functions. I want it to be accessible only by this function. So write static here. Static here. Yes. That global variable property out of 2 property, 1 property, what is that? It will be there throughout the execution time of a program. So yes, static variables are the variables which remains always in the memory, always in the memory. They are just like a global variable. Only the difference between global and static variable is global variable can be accessed in any function. Static variables are accessible only inside the function in which they are declared. Now if I run this program now, static variable, how it works? Same way, same result. First time when it is called v is 0, then a is created, function fun, a is created with value 5 and it will v plus plus, so v becomes 0 to 1 now. Then display what? 5 comma 1, 5 comma 1, and function ends. This is gone, but that remains as it is. In the second call, again, this is not done again. Remember, in the second call, we have written it here. Every time it is not created, it is created only one time. That is at the loading time. Now next, again A is created. A is created for function fun and v plus plus, so the same v becomes 2 and print 5 and 2. 5 and 2. That's it. So the point here is, when you write any static variable, it is not created every time just like other local variables. So whenever you think of static variable, imagine that they are global, but their scope, visibility is limited to a function. That's it. That's it. This is the easiest way to understand static variables. So let us try this. Even I will try and show you. Let us look at static variables. I will have one function. In this I will declare one variable, static integer s, whose value is 10. Now here I will say s plus plus and then I will say cout s and endl. The value of s is 10 and it becomes 11 and this is displayed. So when I call this function fun first time, I'll get the value 11. Let us see. Yeah, 11. If I call the function fun again, then again I should get the value 11. No, this is a static variable. So the value was already 11 in the first function call, then it remains 11 only, then s plus plus will become 12. If it is not static, then it should give again 11. Let us run. Yeah, first time it was 11 and then next time it is 12. Now if I remove static, then see, every time when I call the function, it will display value 11. Yeah, again I am getting value 11. It means that this variable s is declared again and the value is incremented. But if it was static, the variable will not be declared again. It will be declared only one time. That already I have explained you. So these are the static variables that are useful inside the function, and these are more useful in modular programming, that is function programming, function based programming. These are more useful in modular programming or procedural programming, where everything is done in the form of functions. There it is useful. These static variables inside the functions are available in C++. These are not available in Java. So that's all about static variables inside functions. And the static variables inside functions are there in C, C++, but not in Java. Now let us look at the example of recursive function. I have a recursive function here, that is function fun, which is taking parameter n, and a recursive function is one which calls itself. So this is calling itself. So a function calling itself is called as recursion. Now this is having value n, but it is calling with n minus 1. So it is modifying the value so that at one time it becomes less than or equal to 0, so that function can stop calling itself. So every recursive function must have some condition so that it terminates after some calls. Now from the main function, I am passing 5 to this function fun. Let us see what will be the output. So it is printing 5, 4, 3, 2, 1. So let us see how it is working. So for that, I'll put a breakpoint here and I will run the program. See here in the watch, the value of n, you can see it is 5. Then it has entered in 5 is greater than 0. Yes, it will print this one now. It will come inside and print. So if I continue execution, then it will print 5. Then it will call itself again. Now again a new call. So what is the value of n now? That was 5. Now it became what? 4. Now it became 4. Yes, it has become 4. Now if I continue execution, then let us see what happens. 4 is greater than 0, so it will print 4. Then it will call itself again, and now this time the value of n will be 3, because 4 minus 1 is a 3. Now the new call, there's a new function call with the value of n as a 3, and 3 is greater than 0, so it should print 3 and call itself again with 3 minus 1, that is 2. So let us continue
execution, print 3 and call itself with 2. Now the value of n has become 2, right? 2. So it is calling, right? So now it will be 2 minus 1, so it's going to be 1 if I continue execution. Continue, print 2 and call itself again. Now the value of n became 1. Yes, 1. 1 is still greater than 0, so it's going to print 1. Then it will call itself again with 1 minus 1, that is 0. So I'll continue execution. It has printed 1. Then it has called itself again with n value as 0. Now n is 0. 0 is not greater than 0. So 0 will not be printed and it will not call itself again because this is inside the condition. Because the condition is false, so it will not enter inside, so it will not call again. This call will not be done. So let me continue execution. Yeah, it has came to the end of a function. Now watch carefully. If I print execute again it is coming back to the end of a function. Again coming back. See, it has called itself total 6 times. 5, 4, 3, 2, 1 and 0. So it has called 6 times. So 6 times it has to end the function. Ending the function. Ending the function. Next. Now it has came back to the main function. So that's it. I'll stop this. So this is how recursion works. Now let me make some change in this function and show you the execution. Now let us write this print after the call. Now let us see what is the output. I'll remove the breakpoint and I'll show you what is the output of this function. So only the difference is that I have written cout after the call. So the output is 1, 2, 3, 4, 5. So it is printed in the same order. So how this is working? I'll put a breakpoint on if and I will run. Now see the value of n, that is 5. So it will enter inside. Condition is true. So it will first line inside if. See, this is the first line inside if. So it is calling itself again. So it will call again itself with value 4. So now again it has came from here inside and the value of n is 4. Right? Value of n is 4. Then 4 is also greater than 0. So 4 is greater than 0. So it will enter inside and the first line is 4 minus 1. So again it will call itself. So I will just make the calls. Now the n value is a 3. Now n value is 2. Now the n value is 1. Now see, this n value is 1. So 1 minus 1, 0. It is going to make a call again with the value is 0. Now again it is 0. So 0 means it is not greater than 0. So it will not enter inside if and it will not call the function. It will not call the function again and it will not print the value of n as 0. It will come out. Now let me continue. It will come out. Yes, you can see that it has reached the end of the function. Now if I continue, you remember it was calling itself every time, but it has not yet printed. So it will go back to the previous calls and start printing. So it will go back to this call, right? Where you can see the value of n is what? 1. Oh, just now it was 0. So it is in the previous call. Previous call it was 1. And print 1. That's it. It will go back to the previous call. So previous to this one it was 2. Now you can see that the value of n is 2. Value of n is 2. Yes, it is going to print a 2. It will print 2. Then go back to the previous call where the value of n was 3. Now the value of n is 3. So it will be printing 3. Yes. Let me continue. So it will print 3. Yes. Again it will go back. See, it's at the end of the function. It will go back now. Right? It's at the end of a function. So it will go back to the previous call where the value of n was 4. So it will be printing 4. Then again, previous call where the value of n was 5, so it will print 5. That was the first call, so it has returned till the first call and now back to the main function. And that's all. This is how recursive functions work, and recursive functions are more similar to loop, but these are more powerful than loop. So at some places where the loops are not useful, we use recursion, and sometimes we can use either recursion or we can use loop. So recursion is better than writing loops, but it's difficult for
understanding its working. So once you spend some time on recursion and learn how to write them, then definitely that looks a lot easier than writing loops. So that's all about recursion. Here is an exercise program for linear search. You are supposed to write this program using function. You should have the list of elements in an array. An array should be passed as a parameter to a function for searching a given key element. So you should know what should be the name of a function, what should be the parameter list of a function, and write the logic for linear search. Already we have seen linear search logic. So here I will run the program and show you how the input and output of the program should be, and even a PDF of a program is given as a resource. You can check if you need it. Yeah, here is a program for linear search. Already I have discussed and explained what is linear search, how it works, but we have to write on the program using a function. A function should take the array of elements as parameters, that is number of elements, and the key to be searched. So you have to write on the same program using functions. So more focus here is how to write a program using functions. I have given the name of a function as search. Let me run the program and show you. Already I have given the list of elements here. It will be searching within those given elements. Now here it's asking for the element to be searched. I have an element 9 available in my array. So element 9 is found at index 5. I'll run the program once again. I'll give the element as 12 now. 12 is not there in my array list. So now it is giving the index as -1. So that's what, if the element is not found in the list, it should give the index -1. If it is found, then it should return its index. So try this program by yourself, and if any difficulty, you can check the program in PDF.